for operators to understand how distillation systems work, because it's part of their job to make sure the systems run properly. The purpose of any distillation system is to separate a liquid mixture into two or more components. The separation takes place in a distillation column or tower. The liquid mixture is called feed or charge, and the components into which it's separated are called cuts or fractions. Let's take a look at a simplified representation of a distillation system. In this example, the feed is stored in a tank. During operation, a pump is used to move the feed from the tank to a preheater. In the preheater, the mixture is heated under pressure to just below its boiling point. The pressure in the tower is lower than the pressure in the preheater. So when the feed enters the tower, it starts to boil. The vapors from the boiling liquid, which primarily contain the lighter components in the feed, rise in the tower. The remaining liquid, which consists primarily of the heavier components in the feed, moves down the tower and collects at the bottom. Some of this liquid is drawn off as the bottom's product, and some of it's routed to a device called a reboiler, which is connected to the bottom of the tower. The reboiler is usually a heat exchanger that's designed to vaporize the lighter components that remain in the liquid from the bottom of the tower. Vapors from the reboiler, or in some cases a mixture of vapors and liquid, re-enter the tower. The vapors then rise up in the tower. These vapors and the heat they contain are often referred to as boil-up. The hot boil-up provides heat that's needed for the distillation process to take place in the tower. The vapors that rise up in the tower are routed to a condenser. The purpose of the condenser is to cool and condense the vapors into liquid. From the condenser, the liquid flows into a receiver or accumulator. The receiver provides a reservoir for the liquid. Part of the liquid from the receiver is pumped back into the top of the tower, and part of it is drawn off as the tower's overhead product. Well, we've just looked at one simple example of a distillation system. Not all distillation systems are the same, but most of them have the basic equipment that we've just seen. At the heart of a distillation system is the distillation tower. Basically, a distillation tower is a series of distillation processes, or stills, stacked on top of each other. The process of distillation is sometimes referred to as fractional distillation or fractionation, and distillation towers are sometimes called fractionators. Fractionation is distillation that occurs at different levels in a tower. This is a simplified illustration of the inside of one type of distillation tower. This tower uses trays called sieve trays to separate vapors and liquid. The trays are spaced throughout the tower. They're called sieve trays because they have many openings in them, like a sieve. Here's a closer view of some of the trays. We've exaggerated the size of the openings to make them easier to see. The openings in the trays allow vapors to rise through the trays on their way up the tower. Each tray is also designed to hold liquid. Dams or weirs on each tray allow liquid to build up on the tray. Liquid that overflows the weirs flows into downcomers. The downcomers channel the liquid from tray to tray down the tower. When the upward moving vapors and the downward flowing liquid come in contact on each tray, the vapors transfer some of their heat to the liquid. Two things happen. The heavier components of the vapors become cooler and condense into liquid, and the lighter components of the liquid boil. The vapors then rise toward the next tray. As this process continues, the rising vapors contain a higher concentration of lighter components and a lower concentration of heavier components. So this is how the distillation process is repeated on each tray as the vapors rise through the tower. Now, not every distillation tower is designed in the exact same way.